Hello students, today we will solve exercise problems of chapter 1, electric charge and electric field. The first one is, what is the force between two small charged spheres having charges of 2 into 10 raised to minus 7 coulomb and 3 into 10 raised to minus 7 coulomb placed 30 centimeter apart in air? How do we solve it? Always start with data collection. So here we have Q1 given 2 into 10 raised to minus 7 coulomb, Q2 is 3 into 10 raised to minus 7 coulomb, and distance between the two is 30 centimeters. So in MKS, if you convert, it is 0.3 meter. And what we are asked to find out? Electrostatic force. How do we do this? Very simple. Just apply scalar form of Coulomb's law. Which says that F is equal to K Q1 Q2 by R square. What is K here? 9 into 10 raised to 9 SI units. Okay, so substitute values and you'll have your answer. Second problem, the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. What is the distance between the two spheres? What is the force on the second sphere due to the first one? So let us collect the data first. Again, here we are given Q1 0.4 microcoulomb is 0.4 into 10 raised to minus 6 coulomb. Similarly, Q2 is minus 0.8 into 10 raised to minus 6 coulomb. And we are told that in air force is 0.2 Newton. What we are asked to find out? Firstly, we are asked to calculate distance between the two. And then we are asked to find out force on second sphere due to first one. So if we label it as F21, we have to find out how much is F21. Now A is very easy. Again, we have to apply scalar form of Coulomb's law. So K Q1 Q2 by R square should get us our answer. We have Q1, Q2 and R square. Sorry, R square we don't have, but make it subject of formula. We have F given, so you can find out R. Now, suppose if the answer F is say 1 Newton. What is 1 Newton? It is force on Q1, force on Q2, or it is total of Q1 and Q2. Means half Newton is on Q1 and half Newton is on Q2. What is 1 Newton? 1 Newton, if K Q1 Q2 by R square is 1 Newton, then that force is force experienced by Q1 as well as Q2. Okay, so whatever is the answer of F here, it is force experienced by 1 as well as that by 2. So we can say that F12 is equal to F21 is equal to F. And be careful, here we are talking only about magnitude of the force, we are not talking about the direction. Let's see third one. Check that the ratio Ke square by G Me MP is dimensionless. Look up a table of physical constants and determine the value of this ratio. What does the ratio signify? Okay, now let us try to understand the problem. Here, what is K? We know that K is 9 into 10 raised to 9 SI units. E is charge of electron as well as proton. Capital G is universal gravitational constant, M is mass of electron, MP is mass of proton. So what is this quantity? Obviously, if we look at the values of all this constant from some standard book, we can gather all the values, and by substituting in the given expression, we can get answer also. So here you have all the values given. You can determine the value of this ratio. And what about the dimensions? So I leave it up to you. Substitute unit of K, E, G and Me ampere masses. So substitute units and simplify units as well. But how do we get this? What is this expression signifying? So we know that electrostatic force is given as kq1 q2 by r square, isn't it? Force between two charges at r distance is kq1 q2 by r square. Similarly, we have gravitational force also, which is gm1 m2 by r square. Now, what if I take ratio of these two? Now consider that here I am talking about electron and proton, then q1 is E and q2 is also E. What I'll have as Fe, k E square by r square, isn't it? And electron and proton may have masses Me and Mp. Then Fg will be G Me Mp by r square, and take ratio of these two. What you will get? R square will get cancelled out, and you will be left with k square by G m1 m2. And that is exactly what we are given. So I can say that this ratio is the ratio of electric force to gravitational force. It is indirect comparison between electrical force and gravitational force. And looking at the ratio, we will realize how much strong electric force is as compared to gravitational force, which is the weakest force in the previously considered fundamental forces. In fourth one, we are asked to explain the meaning of the statement electric charge of a body is quantized. And why can we uh, ignore quantization of electric charge when dealing with macroscopic charges? Now, let us first talk about A. Now, we know here that quantization of charge, the statement itself says that any charge found in nature is integer multiple of fundamental charge. So you can transfer 1 electron, 2 electron, 3 electron, 4 electron, but you cannot transfer 1.5 electron. You cannot transfer 2.5 electron. That is why all the charges found in nature are integer multiple of fundamental charge. Q is equal to Ne was the equation. And hence we say that any body which is having some charge must have quantized value of charge. Okay, so to understand this better, you may go to the lecture explaining quantization of charge. As far as B is concerned, when you are talking about large scale charges, adding or removing few electrons won't affect the value of charge to great extent, because value of charge of 1 electron is 1.6 into 10 raised to minus 19. So when you are talking about macroscopic body which is having large amount of charge, and there you add few electrons, you remove few electrons, it is not making very great difference to the overall value of charge, and hence we can say that one can always ignore this quantization of electric charge if you are talking about large amount of charge. Now we have the problem of electrostatics, where we are producing charges. We are told that when a glass rod is rubbed with silk cloth, charges appear on both. A similar phenomena is observed with many other pairs of bodies. Explain how this observation is consistent with the law of conservation of charge. Now, let me first focus on law of conservation of charge. What law of conservation of charge says? It says that if your system is electrically isolated, means if charges have no way to come in or get out of the system, then overall amount of charge will remain constant. Now, when you are rubbing a glass rod and silk cloth, what happens? Electrons will transfer from glass rod to silk cloth or silk cloth to glass rod. And suppose if I assume that glass rod is losing electron and silk cloth is getting electron, in that case glass rod will be positively charged, silk will be negatively charged. But there is no entry of any charge from outside the system. So net amount of charge is conserved, isn't it? Previously system was electrically neutral. Afterwards also, after rubbing also, system is electrically neutral. Charge is transferred from one body to another, but charge is not added to the system. So we can say that law of conservation of charge is obeyed here. Now, how do I know who will be positively charged and which one will have negative charge? So for that, you will have to refer to previous table. In one of the lecture it was given, which is indicating electron affinity. The one who is having more electron affinity will get electron and other one will lose electron. So to answer that question, that if glass is rubbed with silk, who will be positively charged, who will be negatively charged, go back to the table and find out the answer. Four-point charges QA is equal to 2 microcoulomb, QB is minus 5 microcoulomb, QC is 2 microcoulomb and QD is minus 5 microcoulomb are located at the corners of a square ABCD of side 10 centimeter. What is the force on charge of 1 microcoulomb placed at the center of square? So let us first understand the situation. We have a square and side length is 10 centimeter. Okay, and we have four charges, namely QA, QB, QC and QD. Okay, and let us place one more charge at center. We call it QO. What is the task? Find force on charge 1 microcoulomb. Here is 1 microcoulomb at center. Now, how do I find out? So if I apply law of superposition for electrostatic force, what I need to do is find out force on O due to A, find out force on O due to B, O due to C, O due to D. So if I call it FOA, FOB, FOC, FOD, first I should be able to find out four forces and then take vector sum. Don't simply add four numbers. You should consider direction and then take vector sum. And then you can find out force on O. But I think task here is simpler than that. If we consider values and if we look at the direction. Let us start with A. Now see, what is QA? QA is 2 microcoulomb. And what is QO? 1 microcoulomb. So 2 and 1 both are positive charges, so there will be repulsion. So force on O due to A will be away from A, isn't it? They have repulsion. So A will push O towards C, isn't it? And what about O and C? QC is 2 microcoulomb and QO is 1 microcoulomb. So again there is repulsion, means that C will try to push O towards A. Moreover, force on O due to A is K2 into 1 by R square. Force on O due to C is K2 into 1 by R square. So FOC and FOA both are equal and opposite forces. So what is the resultant force on O due to A and C? 0. So these two forces are of getting any resultant force on O. Okay, and hence the resultant force on O and C is 0. What about B and D? So look at B value. B is minus 5 microcoulomb and O is 1. So there is attraction. So what B will do? B will pull O towards it. And D is also negative charge. So D will also pull it towards it. And then again we have similar situation. Force on O due to B and force on O due to D. Both are equal and opposite. And hence what we can say, they will negate each other. They will nullify each other. So OA, FOA is balanced by FOC. FOB is negated by FOD. And hence what is the resultant force on QO? 0. Okay. So in exam, when you are writing the solution, you should first explain that what is FOA, just mention magnitude, that FOA is equal to FOC is equal to K 2 microcoulomb into 1 microcoulomb by distance square. Let it be result 1. Then explain that these two are equal and opposite, so resultant of the two is 0. Then similarly write magnitude of FOB and FOD, it is K 5 microcoulomb into 1 microcoulomb by distance square, and then explain that these two are also equal and opposite, so resultant force is 0. Now we have seventh one. In first question, we are told that an electrostatic field line is a continuous curve, that is, a field line cannot have sudden breaks. Why not? One more question we have. We are asked to explain why two field lines never cross each other at any point. So let us address first one. Why electrostatic field line is continuous curve? Now we know that gravitational force and electrostatic force, they have one common characteristic between them, and that is they have the range up to infinity. So suppose if you have two electrons, which kind of force they will have between them? They will be repelling each other. What if you increase distance between them? They will still be repelling with weaker force. You take them to extremely large distance and yet they will repel each other, even though the force of repulsion will grow more and more weaker as you increase distance, but there will be force of repulsion. And up to what distance they repel each other? So the answer is they repel each other even at infinite distance. So electric field lines, they go up to infinity. For any point charge, the influence is its electric field. And how do we describe electric field? We describe it by electric field line. So for given charge, how do I describe its electric field? We draw electric field line, but up to which distance we should draw electric field line of any charge? Up to infinite distance. Unless if it is a positive charge and if the field line encounters some negative charge, then it will end. But there will not be any sudden break in electric field line. Okay, so electric field line starts from positive charge, ends at negative charge. And what if there is no negative charge? Then field line will continue moving in the direction it is started. Okay, so there is no sudden break in electric field line. Coming to second one, why two field lines cannot intersect? Now we know that when we have curves of electric field lines, at any given point when we draw tangent, the tangent indicates direction of electric field at that point. Now if you have two electric field lines intersection, suppose you have one electric field line going like this and other electric field line going like this. Now for one field line, if I draw, I can draw it like this, and for the other field line the tangent will be going in some other direction. So two tangents indicate two direction of electric field at this particular point. So at one point you cannot have two directions of electric field, and hence we can say that two electric field lines can never intersect each other. Now let us move to last problem of this session. In 8th one, we have 2 point charges QA, which is 3 microcoulomb, and QB, which is minus 3 microcoulomb, are given, which are separated by 20 centimeter distance. What is the electric field at the midpoint O of the line joining the two charges A and B? First question. Second question, if a negative test charge of magnitude 1.5 into 10 raised to minus 9 coulomb is placed at this point, what is the force experienced by the test charge? So two questions we have for the two charges. What is the electric field and what is the force at some given point? And 10 raised to minus 9 coulomb is the negative charge. So let us first collect data. Here we have QA and QB given, and distance is also given between them 20 centimeter, and apart from that we have one more charge QO at midpoint placed, which is minus 1.5 into 10 raised to minus 9 coulomb. What we are asked to find out? We are asked to find out electric field at O point. Where is O point? O point is placed in such a way that distance of O from A and distance of O from B is same. It is midpoint, so distances are 10 centimeter, O to A and O to B. And then we are also asked how much is the force on the charge QO. So how to approach it, how to start? Let us first try to understand the situation. See, two charges we are given, QA and QB, and we have midpoint O. So first, if I consider electric field, we know that for positive charge, electric field lines go out. So for positive charge QA, electric field must be going in this direction. So this is the direction of electric field at O due to A. Now B is negative charge, so field lines go towards the negative charge, and hence this is the direction of electric field at O due to B. Now if I am asked to add the two, because both EOA and EOB both are in the same direction, so we can simply add the two. So now how do we find out electric field at O due to A and electric? We have electric field can be given as KQ by R square. So when you are finding out EOA, it is KQA by 10 centimeter square, and similarly EOB is KQ by 10 centimeter square. Okay, so EO should be easy to find out. Now when we place third charge QO at midpoint, and then if we are asked to find out force on QO, what we should do? We know that A is positive charge and O is negative charge. So what A will do? It will pull O towards it. So this is the direction of force on O due to A, isn't it? And then B is negative charge. QO is also negative, so both will repel, so B will push O away, and then force on O due to B is also in the same direction as that of FOA, and hence if you want total force on QO, you should simply add the two. So FO is FOA plus FOB. What is FOA? KQA QO by 10 centimeter square. FOB is KQO QB by 10 centimeter square. Be careful. Instead of 10, you should take 0.1 meter. Okay. Now, this is one way of doing it. Otherwise, we have one more way of finding out force. Once you have electric field, what we can do is use this formula. F is equal to Q into E. Okay. So simply multiply E at O with QO. Okay, and you should be getting force on O. So check answer by both this method. Now this particular problem has many variations. So think of the possible variations. The charge values may be changed. Both charges may be negative. QA and QB both may be positive. QO may be positive charge. Then in all this possibility, how the answers will vary. That is also interesting point to ponder over. So think of that. Okay, so we are done with today's session. For the remaining problem, we'll discuss in next session. Thank you.